Moving on from what we've been doing in chapter 1 and chapter 2, we're going to move into solving equations that are linear. They're going to be in two variables, but instead of saying that there's an infinite number of solutions on the line, which is any point on the line, we're going to be looking at what is a solution that satisfies two lines. So for example, if you look at this graph that's titled Take a Hike, and it gives you participants as your Y value and years since 2000 and your X value, and it says what is happening when the graphs cross. Well, if you look at the blue graph, it's representing the number of participants who fish, and the red graph is looking at the number of participants who hike. Where they cross, just after 2008, kind of between 2008 and 2010, they have the same number of participants in the same year. So if you look way back here in 2002, the number of people hiking was much less than the number of people fishing. But then the number of people fishing was declining. It had a negative slope. And the number of people participating in hiking over time is increasing and has a positive slope until eventually here they meet. So when the graphs cross, the number of people hiking and fishing is the same that year. So it's something that is a solution for both of the equations. So this is what we're going to be exploring, is how do you find the solution of a two-variable system when there's a system of equations you're satisfying? So the first thing I want to look at is the first objective, which is deciding whether an ordered pair is a solution of a linear system. So an ordered pair is a solution to a system if it satisfies, and this is the key thing, it has to satisfy both of your equations. Why both? Well, if you look at an equation of a line, if I have an equation of a line here and I say, oh, this point satisfies this, but my other line's here, that point's only going to satisfy one of the lines. It's not going to be this point. This is the only point that will satisfy both of the equations. So how do you decide whether a given ordered pair is a solution to the given system? You have to substitute it in for x and y in both of the equations. So we'll start with 2x plus y equals -6. If I plug in x is 3 and y is -12, does that equal -6? Well, on the left-hand side, I have +6 minus 12, which is -6. So yes, 3, -12 is a point on this line. So then we try it in the other one. If I plug in x is 3 and y is -12, does that equal 2? So I get 3 minus, what is that, 36, which is -33. So it does not satisfy the second line, so therefore 3, -12 is not a solution. All right.